Hey everyone. So this week we're reading a story from the Pioneer Press. It's a little bit older, as you can tell, but as you also, I think, experienced from this class session, one of the big challenges for doing data-driven work and data-driven investigations, and you know from your own experience, is actually getting the data. So this Pioneer Press story is an example of using linear regression in journalism, right? So basically, what we're going to do this week is we're going to replicate a version of the Pioneer Press story using some data from the state of California. So the Pioneer Press story focuses on how schools with a high proportion of lower income students, some are still exceeding expectations. And the way that they did this was through a linear regression. So what we're going to do is actually use some data, as I mentioned, in the state of California. This is a method of collecting data that isn't used anymore. It's the Academic Performance Index. But they do have it archived on our website. And so we're going to be looking at a version of the 2012 base API data. Now we have here, fortunately, still a record layout for this. So this gives us a sense of what's in the data set. And we're actually working with a slightly smaller data set that doesn't have every possible field name, obviously, but gives us the things that we can sort for. So in particular, we're going to look at meals, which is the percentage of students that are eligible for free or reduced lunch. This is a proxy that's very often used for measuring the sort of income situation of students in school. It's definitely not foolproof, and we can talk in detail out in class about whether this is a good measure to use, but it gives us a place to start with experimenting with linear regression. And then, of course, we're going to use the API. I can type it. The API 12B, so that's the base, that is the score that the school achieved on this particular index test. So to do this, obviously, we're going to need some code, and we're also going to need additional libraries. So I'm going to go ahead and save this as, let's see, CA example. Let's say CA API regression. Okay. And you can see that I have in there, I have a CA of data that I'm looking at. But I've gone ahead and downloaded a copy of that that we're going to pull into our Python. So the first thing is we need to import our packages, of course. Let me just pump up the volume here, as it were. So I'm going to import pandas for this, even though I'm not usually a huge fan of pandas. And I hate the autocomplete. I'm also going to import NumPy, or D, and I'm going to import Plotlib. So no surprise here, right? Where we want to be able to do stats and also visual data. The other thing I'm going to do here is for this exercise, I'm going to use sklearn. So sklearn is a machine learning package that we're going to be using a bunch throughout the rest of the term. And we're specifically going to support the linear regression model. Now, there's also another set of packages. There's another package, staff models, which has a slightly prettier output, but for now, we're going to start with visualization aspect and look at data. So first things first, go ahead and let's load data file. Oops. So call this CA API data. Right. Read CSV and maybe LTX.cd And I'm just print. Right. Very, very simple here. I'm going to pull up my. Okay, so we have the basic shape because we don't have all of the we don't have all of the columns that exist or that could exist according to our regs layout. That's fine. So the thing we're going to look at today again are that API 12v value. That's the value of the API for 12th graders, the academic performance index, and we're going to look at where is it here? Meals, right? So meals is the percentage of students who are on free or reduced lunch. So it looks like we're pulling in our data just fine. That's always a good thing. So the first thing that I want to do is just make a quick histogram of the API column. And so I'm going to grade 12. And because I'm in just a file here, I want to make sure that I name my plots so I actually have different plots. And whoops. And here I'm make sure that I have right, and I'm just a histogram. Again, very simple, nothing too fancy going on. So let's just take a look at that. We're gonna get the printout of our data. Oops. Always forget that plt.show, right? Let's try that. So there's a histogram of achievement. We see that it has a slight right-hand skew. So looks like the mean and median is somewhere around 800 or so, if we're just eyeballing this. And now what I want to do is create another figure that's going to look at the just get it here. I'm going to make of okay, so again, very simple here. I'm going to give this another name so that I get a plot, and again, just have to say meals, right? His, and I only need a single show function in order for both to show up. And so here I have two, right? What I have on this one is this is my API. Those are my API scores, and here I have sort of the I have the percent of students across schools who are on free or reduced price lunch. So there's a right skew both of them. Unsurprisingly, it goes from 0 to 100 when it comes to students on free or reduced price lunch. And 1,000 is obviously appears to be the max score for the academic performance index. And our peak is not all the way to the right. So again, this is just to give a sense of sort of how the data is shaped. Now the question is, how do we plot a relationship between them? How do we actually look at these things? So what I'm going to do is go ahead and create a scatter plot. So again, this is really just giving me an intuitive sense, a visual sense of what the relationship might be. Make a scatter plot of versus API, and I just do it by saying plot and right, so treating important that I'm treating the reduced price lunch percentage is an independent variable. That's why it's on the x-axis, and achievement as the dependent variable, right? That's essentially the relationship I'm telling you. I'm saying we don't have to, there's an independent variable, which is how many percentage of the school are on reduced lunch, and the dependent variable trying measure is their test score, the 12 test scores for them. So let's just see. I think this won't. I'll find out. I get a weird thing here. I'm either going to get 3 or I'm going to get too much up. Okay, so here are my original histograms, and here is my scatter plot. So what I'm seeing here is what looks to the naked eye, right? It's roughly like kind of a slight downward trend, right? If I have 0 students getting free or reduced price lunch, then I'm seeing some clustering in the top scores. As that increases, as there's an increase in percentage of students receiving free or reduced price lunch, I see what looks like a downward trend in achievement, right? And so this is essentially what we're measuring. This is the sort of basic inference of the Pioneer Press story, is to say that, there does seem to be this performance relationship when it comes to looking at the income of the students. And so in order to find a story in this, what we are looking for, right? Again, we always want to think about, are we looking for the typical case or are we looking for outliers? And so what the Pioneer Press focused on was, where are the schools that are performing better? Like, we can just from an eyeball see that obviously, while some schools with, 100% of students are qualified for reduced price lunch, are doing very poorly. Some of them are doing actually really well. And so all we're doing here is treating linear regression, treating this relationship as a predictor and saying, look, we can draw a line and say, where do we expect school achievement to be on the basis of this fact? And given that, which ones are the schools that are outperforming on that basis? So it's a pretty simple hypothesis here. I'm going to say in some ways it's too simple, but we will look at how to actually chart the relationship, make that quote-unquote prediction, or sort of visualize that prediction, identify some outlier schools that we could then use as a basis for future exploration. Now, there's more to discuss here about how we approach this, how we would actually approach this, and specific things that we look for doing in the regression. But for now, we're just going to focus on kind of the rough and ready, the rough and ready visualization, kind of the intuitive approach to this. So I will be back here in just